Good afternoon, everyone. So the title for today's presentation, it's template-based graph generation in Python and its maintenance in Git. So I hope you're excited to learn a thing or two about Python and plotting graphs. Okay, so if you look at visualization in the clinical world, it's an upcoming field. So in finance and other sectors, visualization is very popular, but it's really new in the clinical world. And you can say that it's commonly used to check the quality of the data, like we saw in the previous presentation, to look for trends of missing records, to check for duplicate records, to check for any unusual trends in your findings measurements, because often a mountain of data in a table, it can easily be understood if you just visualize it. And also the clinical safety review part. So if you have clinical trials happening in different clinical sites, you can track the adverse events at different clinical sites and check for risks. So again, easy to understand data if you visualize the data. And the most common place where it's used to understand the outcome of a study, most commonly for endpoint analysis. And more recent, understanding real world data. So the data which comes from the Fitbit which you use or any other wearables. This is a very upcoming field and a lot of big data is coming in from there. So yes, visualization can really be helpful in understanding this data. Okay, so data visualization tools. So if you divide the visualization tools into two, there are people who follow the programming approach and people who follow the non-programming approach, either by using Spotfire, which is very common in the pharma industry, or the good old Excel, and Tableau is very common in the finance sector, or the new SAS Viya. And the programmers, they go for SAS, which is again very common in the clinical world, or R, which is very popular these days. And then there's Python. When I asked around, I didn't come across anyone who uses Python in the clinical field. So it's relatively new, which is why I want to discuss about using Python and why I personally like Python as a tool to process data and visualize data. Okay, so data visualization in Python. As you know, open source, and there's common belief that Python is for experts. Yes, it's a high-level language, but it's not really for experts. It's also for beginners. So if you're really a beginner, Python can be a very good language that you can start with. And then you can do more with less code. So yes, a few lines of code can get you a long way in Python. Then readability of code. The code in Python, it's beautifully structured, so it's very easy to understand the code. Again, good readability means good debugging. I learned all my Python by just understanding the log which Python gave me every single time. So very good debugging process. Then when it comes to data visualization, there are some amazing packages in Python. So for the standard graphs, you have this matplotlib. So matplotlib is from MATLAB. So if you have used MATLAB in your past, all the graphs which you plot in MATLAB, it's the same kind of graphs which you can plot in matplotlib. And then because R was, you could use R to make beautiful graphs. So Python also has Seaborn for beautiful graphs. And if you are familiar with R, you have the ggplot2. So in Python, you have the same ggplot2 functionalities in ggplot, and then plotly. So plotly is a graph for interactive data visualization. Or in simple words, if you want to make animated graphs, you can use the plotly package, which is available in Python. So the graphs I show in this presentation, I made them using plotly because it's relatively new, and I thought would be nice to discuss that. And then the data processing. So I'm sure you've heard it a lot of times that Python is very powerful when it comes to data processing. for mining data, filtering data. There are some good data processing packages like pandas, numpy, and so on. And the real data, the real world data we talked about in the previous slide. So I expect in the clinical world, a lot of big data coming in, and Python can really be helpful in analyzing this big data. All right, so let's talk about plotting. So if I ask you to plot a graph and you get this kind of data, as you see on my left side, where you have the subject, the treatment, the age group, and the gender. We used to plot, we filter this data, okay? We filter the age group, the male and female, and then you plot. So let's say there's another person who wants to plot a graph which looks like that. The person starts with the same process of filtering and then plotting. All right, how can we make this process easier? This way, having your own custom package. So when I say custom package, this template graph library, which you can develop with different kinds of graphs. So if there is a data like this, you can go pick a graph from your own custom package, run the function, and then make a graph like this. I hope this is clear. So you make your own template graph library with different functions. Each function, if you call, it codes for a certain type of graph, which is highly customizable, and you can plot your own graph. Okay, let's take a look at one of the graphs from my template graph library, which was plotted using Plotly. This graph. So this graph is an interactive vertical bar graph. So if I just simply move my cursor, I can interact with this graph. All right. Some features of this graph. It's based on a code, and the code it's very flexible. You can add different kinds of features. For example, if you want to change the distance between the two bars here, you just need to change a simple code and you can get the desired distance. Size of the titles, size of the legends, color schemes, and also hover data of your choice. For example, here, if you want to see, say, the mean value of the weight of all the women, you can add that variable, add that column to the hover data feature, and you can see that. Another way I customized this graph is by adding a drop-down menu here. So in this frame, you can see the variable sex, and you can see male and female. You can pick this, and you can just see the females. And if I just click this, you don't see anything. But if you click this, you see all the males. So which is very nice. And another interesting thing, you can see another variable as well. So I've added another variable arm. So in the same graph, I have the drop-down menu. I click on arm, and then it goes to another graph. So you have three treatment variables in there. Again, you can interact with the graph, and you can do any kind of data exploration which you'd like to do. Okay, so themes. So if you're not interested in coloring your graph, Python packages come with different kinds of themes like dark mode, light mode, and so on, which you can just apply simple code again and make beautiful graphs. Okay, here is another graph. Let's say you want to add more elements to your graph, a reference line, a trend, in this case, a reference line at this XY axis, or if you want to add a trend line, this is also possible and very simple. So in Python, a graph, it constitutes of different kinds of elements. So and they are called traces. So each trace, so the line which you see on the top, it's a trace. This pink line is another trace. And each trace comes from a different column or different data set. And then you combine all the traces together to make a graph. Okay, we'll see more about that in the next slide. Also, in this case, I didn't want a vertical axis, so I just removed the axis and I added values here on either side. So again, highly customizable. Flexible axis, yes, we talked about it. And also you can hover the data and you can see the different points, different values. Okay, so like I said, these graphs are based on template codes. And in general, a template code has a certain structure. I would like to quickly go through a simple template code structure in Python. It starts with importing the packages which you need. So in this case, I import Plotly, and I import a submodule in Plotly, which is graph objects, and I import another package which is called pandas for reading the source data. And then this is the function which I am going to make for a certain kind of graph. So you define the function. And the first basic step would be to create your data frame, that is to read, in this case, the CSV file. Again, simple step. And then you instantiate a figure object. If you're used to Java, you know what this means. It's just an easier way to address the different objects in your library. And then you add traces. So in the previous slide, I talked to you about traces. So the different lines in that line graph, they're all different traces. So for example, if I say figure.addTrace, I get the first line, and then I can do all kinds of modifications with that line. And then I add the next line, and I combine all the lines together. And in the end, I update the layout, which is updating the aesthetic features of the graph. So the title, the size, the grid lines, anything that you like to change. So you add traces, and then you update the layout. And then in the end, you create the output. So you can send the output as PNG, PDF, HTML in my case, because I made an animated graph, and so on. And if you run this, you get the graph which I showed you in the previous picture. Okay, more graphs. Just to explain in detail. So this is a box plot, and this is the first one you see. That's a trace. The second one is a trace. Third is a trace, and fourth is a trace. If you see a sample code, this is how I added the trace. So I created a box plot, which is just go to box, and then from this column, concentration, and just name it, color it, all kinds of things you want to do with this trace, and it'll give me this trace. And then I make another trace, which is for this one, where I say plot only the whiskers, do not plot the outliers, just the whiskers, no data points. Then have it set to this certain color, have the whisker color to be this way, and then I made two traces. Similarly, I make the other trace, I combine them together and make this graph. And also you can see in this graph, there are some nice statistical tasks which you can do. For example, if you just hover the data, you can see the median, you can see the quartiles, you can see the values of the upper fence, and also you can color the suspected outliers, so on and so forth. Different features you can do to make this graph the way you like. Now, if you want to plot more than one graph, that's also possible. With multiple axes, that's also possible. This is directly coming from the data. And I'm not sure if you can see. Yes, there's this variable here, which you can use again to do any kind of data exploration you like. So this is a completion flag. So if you click, if you just want to see all those who completed the treatment, then you can just click this and you can just see the completed patients and then explore data in this way. Let's see. Yes, the interactive column variable. That's what I would like to call this. Okay. Then if you like to have different chart types, so this is one trace and this is another trace. So this can come from two different data sets and you can combine them together in simple lines of code. Yes, if you have long names and if you would like to have a deferred axis, very easy to do that. It's also possible. Moving on, so these graphs, I would call them reusable with a lot of flexible features, and you can customize it based on your plotting routine and version control. Okay, version control. So these graphs are based on template codes, and it's very important to control the version of this code so that you can go back to any version of the code and any version of the graph. So let's say there are different people working in a team and you would like to collaborate with these different people in the team. You can edit features, you can validate the package that you create, and you can maintain a workflow like this to maintain your graphs. How can you do this? So I maintain my graphs in Git. So Git can be used for version control. So this Git repository, you can go for GitLab or GitHub, and you can have a Git online Git repository where you have your codes. I wouldn't recommend having sources or results in the Git repository. And then in your system, you have the same folders. So these two are linked, and then you have your code. So every time you make a change in your code, this code is altered, and the code in the Git repository is also altered. So another great tool which you can use to visualize the process of Git, it's source tree, which again I use. This can keep track of your code activity. So let's say there are two different people working on this code and editing features. Every time someone changes a code or fixes a bug, the person can commit the changes. This is automatically changed in the Git repository. And every time you want to have the latest version of the code, you can pull the latest version of the code from the Git repository. So this source tree is just a medium to communicate with the Git repository. And another amazing feature of this whole Git process is the non-linear development. So two people can work in parallel, not interfering with each other's work, and work on the code in an efficient manner. And source tree can also be used to check the branch history. So you can track the changes, you can check the old versions of the code, any old graph which you want to draw, you can pull it from your history and you can just plot them. I'm sure there are many non-Python users listening to this presentation. So if you prefer, say, SAS as a tool to get data from the database, because SAS is very powerful in that, you can use something called the SAS Viya. So SAS recently introduced the SAS Viya platform with the aim to get all the open source programmers, the R, the Python programmers, and the SAS programmers together. So someone who is comfortable using SAS can continue using SAS, have the data, the source data, everything in the SAS Viya platform, and the person using Python can simply set up a connection, 2 lines of code, very simple, a cast connection with the SAS Viya platform, and continue working on the analytics in Python. So very easy, very flexible platform, which can be used if you want to switch between Python, R, SAS, etc. Okay, so what are the success factors to visualization? It's all about choosing the right tool. It will be nice to know different kinds of tools. It's not about replacing them. It's about picking the right one for the task which you have at hand. Yes, it's not enough that you know Python or R. It's also important to have experience in correlating your data. And collaboration, it's becoming increasingly popular because this started, I didn't write all the code on my own. This was a collaborative approach. We edited features, we found new features, and we built our own package as a collaborative approach. Yes, I also heard some questions concerning validation. Validation in the clinical field, it's definitely important. How I see validation is if you build your own package, you can have a QC process set up to validate your own code. And an open mind. So there are many tools coming in. It will be nice to have an open mind to check out these new tools and how you can adapt it to make your work faster and more efficient. Okay, so this is my summary slide, the key takeaways. So we talked about how data visualization is becoming very popular in the clinical world. And we briefly discussed about having your own customized package or your own customized library of template graphs for plotting. Then we talked about, we saw some graphs showing some interactive plots in Python. Then we talked about collaborating and maintaining the code using Git. And we talked about collaborating with non-Python users with the SAS Viya platform. So I hope you're motivated to check out Python. And if you have any questions, I'll be happy to answer them. Thank you.